Hello students, in this video we will be learning how to find the area of a triangle when the coordinates of the vertices are given. So if we have a triangle, let's say we assume a triangle ABC. Just drawing a triangle where we have A, B and C, and the coordinates of A is say x1 comma y1, coordinates of B are x2 comma y2, coordinates of C is x3 comma y3. Then to find the area of such a triangle, there is a formula, okay, using the coordinate geometry. So area of triangle ABC is given by half, okay, then we have a bracket, then it will be x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2, close the bracket, okay, and the units of that of course will be square units because we are dealing with area of a triangle. So remember, area of a triangle in coordinate geometry is found this way. So this is mostly a derivation of half base into height. See, area of a triangle usually is given by how? Half into base into height. So this base into height is within this. Now how from here it comes here, that I will not be showing here, because you just need to know the formula and apply the formula to find out the area for triangle in coordinate geometry. So let's just focus on that, and that's how you get this half. Actually, the reason why I told you half base into height is because of that reason we have this height. The base into height comes within this bracket. Okay. And how do you remember this formula of area of triangle in coordinate geometry? See, it's half. We have x, y, x1, x2, x3, y1, y2, y3. Okay. Just remember, x1 will always come outside the bracket. All the x coordinates will come outside the bracket. So we have x1 followed by x2 followed by x3. Then look at the sequence. It's 1, 2 and 3. So it is x1, in brackets it will always be y and a difference between the y coordinates. But it is 1, 2, 3. Okay. Next it begins with 2 because this was x1, next one will be x2, and because it begins with 2 it goes 2, 3, 1. So it is, so it's 1 to 2, 2 to 3, and then it comes back 3 to 2, 2 to 1. So have a look. When it is as x1, it is, so when x is here, it is y2 minus y3. When x is here at 2, over here, it is y3 minus y1. Sorry, so it doesn't come to 2, it comes back to 1. Sorry, and then it goes back again. So it's from, when it is at x2, it is y3 minus y1, and then when it is at x3, it is y1 minus y2. Okay, so once again we will do it. Okay, when x is at 1, we have y on both places, so x1, then this will be y2, y3 at 2 and 3 position. When x2 is at 1 position, we will have y3 and y2 at 2 and 3 position, so y2 minus y3. And when x3 is at 1 position, you have y1 minus y2 at 2 and 3 position. Got it? So from 1 to 2, 2 to 3, and from 3 it is 1. Okay, and then again it goes in that order. So same way we have 1, 2, 3, 2, 3, 1, 3, 1, 2. Got it? So x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2, and don't forget the entire thing has half multiplied with it. Okay, so half into the rest of the bracket. So now using this formula we will solve a few problems to find out area of a triangle in coordinate geometry. So the first question under exercise 7.3 is find the area of a triangle whose vertices are, and the first problem is 2, 3, minus 1, 0, 2, minus 4. So first thing is to assume the points as A, B and C. So it's as good as saying we have a triangle where we need to assume 3 vertices A, B and C, and we'll have to assume A as 2, 3, B as minus 1, 0 and C as 2, minus 4. There's no need to draw a triangle. This is just for reference sake since we're beginning the first problem. So we need to assume let A 2, 3, B minus 1, 0 and C 2, minus 4 be the vertices of triangle ABC. Okay. Now area of triangle ABC will be given by half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 in brackets. Now we'll substitute the values of x and y. Half into x1 which is 2 into y2 which is 0 minus y3 which is minus 3, sorry, y3 is minus 4, minus of minus 4, close the bracket, plus x2 which is minus 1 into y3 which is minus 4 minus y1 which is 3 plus x3 which is 2, y1 which is 3 minus y2 which is 0, close the bracket, the whole bracket is closed. I'll solve further. Minus into minus gives us positive 4, positive 4 into positive 2 gives us 8. Next, minus 4 and minus 3 gives us minus 7, minus 7 into minus 1 gives us positive 7. And lastly 3 minus 0 is 3, 3 into 2 is 6, so gives you a positive 6. So we have 8 plus 7 is 15, 15 plus 6 is 21, 21 upon 2, so that would be 10.5 square units. That's our answer of the area of triangle for the first problem. Coming to the next problem, it is minus 5, minus 1, 3, minus 5 and 5, 2. Once again, we'll assume the 3 vertices. Let A minus 5, minus 1 be 3, minus 5 and C 5, 2 be the vertices of triangle ABC. So this would be x1, y1, x2, y2, x3, y3. We'll apply the formula. Area of triangle ABC equal to half into x1 into y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. Close the bracket. Let's substitute the values now. x1 is minus 5, y2 is minus 5 again, y3 is just 2, so it is minus 2, close the bracket, plus x2 is 3, y3 is 2, minus y1 which is minus 1, close the bracket, plus x3 which is 5, y1 is minus 1, minus y2 which is minus 5, close the bracket, whole bracket is closed. Now we'll work this out. Minus 5 and minus 2 gives us minus 7, minus 7 into minus 5 gives us positive 35, then minus into minus 1 gives us positive 1, so 2 plus 1 is 3, 3 into 3 is positive 9, then minus into minus 5 gives us positive 5, positive 5 minus 1 gives us positive 4, 4 into 5 is 20. Okay. When added, this gives us 64, and when divided, this gives us 32 square units. So 2 1 is 2, 32 is 64. Okay. So it's easy to find area of a triangle in a when the vertices are given using the formula. Okay. So with this we have completed question number 1 from exercise 7.3. So if you have liked watching this video, please hit the like button, share it with your friends and classmates. Please subscribe to the channel and do not forget to click on the bell icon to receive notification whenever new video is posted. Thanks for watching. See you in the next video.